Banking of road. Why the banking of road is necessary? When a vehicle is taking a turn on a horizontal curved surface, the force of static friction between the wheels of a vehicle and the road provides a necessary centripetal force, and therefore for a safe turn, the centripetal force must be equal to the force of friction, and this gives you the maximum speed limit of a vehicle is equal to square root of mu s rg, where mu s is a coefficient of static friction. But we know that this frictional force have some upper limit, and that is equal to mu s into n. But in reality, its value is usually not constant as the road surface is not uniform. During the rainy season, road can be wet or oily, and it causes the wear and tear of these tires. Also, sometimes the centripetal force may be less, and therefore the vehicle can get skid. Thus, in real life, we should not depend upon the limitation of frictional force so far as possible. And for this purpose, the surface of the curved road is get tilted with the horizontal with some angle theta, and this is called the banking of road, or the road is said to be banked. We can define banking of road. Here this is a diagram of a vehicle moving on a bank road. The process of rising outer edge of a road over its inner edge, that is a horizontal surface, through a certain angle is known as banking of road. We can define angle of banking, that is the angle made by the surface of road with its horizontal surface of a road is called angle of banking. It is always denoted with a theta. This figure shows a vertical section of a vehicle on a curved road of a radius r, banked at an angle theta with the horizontal. We consider the vehicle as a point object, and also we ignore the frictional force between the tire of a vehicle and the road. Also we have ignored the air resistance. There are two forces acting on a vehicle. One, its own weight, which is acting downward direction, and the second force is normal reaction, which is perpendicular to this horizontal surface road. As the motion of a vehicle is along the horizontal circle, the resultant force, that is nothing but the centripetal force, is directed towards the center of a track, and hence we can write the n sin theta is equal to Fc. This n sin theta is one of the component of this normal reaction. By substituting the value of the Fc, we get the equation 1 as n sin theta is equal to mv square upon r. To balance the vertical downward force mg, we have to resolve the normal reaction into its two components. One is along the vertical direction, that is n cos theta, and one is along the horizontal component, that is n sin theta. So from the diagram, it is found that its vertical component n cos theta balances its weight mg, and its horizontal component n sin theta is in the direction of the resultant force, that is nothing but the centripetal force. Thus in magnitude we get two equations. One is n sin theta is equal to mv square upon r, and n cos theta is equal to mg. Divide the equation by 2, we can write n sin theta upon n cos theta is equal to mv square upon r into 1 upon mg. We can cancel out some term from left hand side and right hand side, and we get sin theta upon cos theta and v square upon rg. So this gives you the equation as tan theta is equal to v square upon rg. Rearrange this equation, we can write the v is equal to square root of rg tan theta. This equation is called as most safe speed of a vehicle on a road for a particular road where r and the theta are fixed. From this equation, we can calculate the angle of banking from the equation 3, and this equation is theta is equal to tan inverse of v square upon rg. This equation helps us in designing the road so that the vehicle can move with the most safe speed.